Okay, here we go. April 29th, end of week 4, geometry. Working on triangle congruency. Tuesday, we finished up with this part of your handout with that acronym Cpctc. Anybody remember what that stands for? It's a mouthful. Corresponding parts of congruent triangles are congruent. So if you've proved that two triangles are congruent, and you've got a congruency statement, then you know that the pieces and parts are also going to be congruent. You know, that makes sense, right? Because congruency requires that every part of each triangle be identical. It's got to be the same for both. And we will actually go through a couple of typical proofs that are in this packet. Be good to take notes when we get to that point, because some people don't like proofs, they don't understand them. But hopefully I can shed some light on that and make that a little bit simpler. So questions on Cpctc? At the bottom of that page, if you have not done that yet, you might want to do that. It's basically just giving you some examples of congruency statements. And remember, when you have congruency statements and you're told by this little symbol here in between that these two triangles are congruent, then you know that the parts that are listed in a specific order are also congruent. So if it's asking you to identify the congruent angles, angle J is congruent to angle P, angle K is congruent to angle Q, angle L is congruent to angle R, because they're in the same position in the congruency statements. First to first, second to second, third to third. You can do the same thing with sides. All the rest of that next page is more of the same. Finding congruency, using these values, these expressions that they plug in here, tells you everything you need to know about the given triangles. So take a look at number 7 to start with. Triangle PHS is congruent to triangle CNF. Okay. So what are the corresponding angles that are congruent? What goes with angle P? I'm going to go ahead and add this to this Jamboard here for a second. So since we're talking about corresponding parts of congruent triangles are congruent, that's why I'm asking you these questions. The congruency symbol right there in the middle of all those letters tells you that those two triangles are in fact congruent. They may not look congruent to you. They may not, I mean, one of them's been rotated. They're not in the same orientation. So how do you make sense of any of this? Well, you rely on the order of the lettering because they correspond. They're in the same relative position. Think about our corresponding angles when we were talking about transversals and parallel lines. It's because those are congruent because they correspond in the same relative position. Same thing works here with these congruency statements. So which angle is congruent to angle P? This really shouldn't be that tough, you guys. What position is letter P in that first statement? First, second, or third? Can you help me out, Audrey? Problem number 7.
Yeah, I don't know.
What position, you have this congruency statement right here. What position is letter P in that triangle description? First, second, or third?
First.
Yeah. So what's the corresponding congruent angle in the other triangle?
C.
C. Yeah. That's all. This isn't deep. This is easy, guys. Letter P, first position. Letter C, first position. You have the congruency statement that tells you those two triangles are congruent. The lettering tells you everything you need to know about these triangles. Any congruent triangles. The order is everything. So first position corresponds with first position. P corresponds to C. Second corresponds to second. H corresponds to N. Third corresponds to third. S corresponds to F. So it looks confusing because now you got these expressions in here. They got 3 different variables. You got X, Y, and Z. You got one angle over here in PHS that's identified with degrees. You got one angle in the other one that's identified with degrees. So how do you figure out what X, Y, and Z actually are? Okay. Here's the problem. And just to make myself some notes, I'm going to break this thing down. P equals C, whoops, capitalize that. H equals N. S equals F. How I know that? All I'm doing is reading the congruency statements. Triangle PHS is congruent to triangle CNF. So if I'm trying to find the value for X here, I got angle H is 6X minus 29. What does H equal? I just wrote it out. We're not going to be able to get through this today if you guys don't start participating. I got 6 people out there on the Zoom. Somebody other than Jonathan.
Wow. It's 115.
Thank you, Audrey. My list right here says H equals N. So that's all you need to know. So to find X, all I got to do is write this equation, 6X minus 29 equals 115. Because I'm just reading the congruency statement. So where is y? Y is in F. So what corresponds to F? S. S, I don't know yet, but it'll be easy to figure out once I know what angle H is, right? Because now we can use the triangle angle sum theory. Three angles got to equal 180. So I'll leave that one for a moment, but it's going to be 3y minus 1 equals something. So what about Z? Angle C corresponds to angle P. Okay, that's 36 degrees. Four Z minus 32 equals 36. Now I got two equations. I need to solve the one for H first, because that will help me figure out what S and F are. X is easy. Figuring out what Z is also easy. But I got to know what angle H is in order to figure out what angle S is. So if I add 29 to both sides of that, the 144, 6x equals 144.
36.
I'm not sure about that number, Jonathan.
Oh, shit. Yeah, sorry.
It's 24.
24.
Okay, so x equals 24. And so H equals okay. I'm making it more difficult on myself. What am I missing here that should have been obvious to me as soon as I started this problem? And I didn't do it on purpose. I already know what angle H is.
Because it's...
It equals N, it's 115. So, I mean, I need to find what X is anyway, because that's part of the problem. But to find S, I just made it more difficult than it needed to be. I really just needed to add 36 plus 115. That's 151. So angle S is 29 degrees. S equals F. So that's my third equation that I needed. 3y minus 1 equals 29. Because that's what S is. S is 29 degrees. If you created this little drawing here, maybe put the 115 up there by that one. And your third angle, once you calculate it, is 29 for S. Should equal 180, 115, 36, 29. Yep. Okay, so that's the benefit of having these congruency statements and understanding what corresponding parts of congruent triangles, understanding what that really truly means. Because that's gonna give you a lot of mileage on figuring out all these kind of problems. You see problems like these last two here on that same page, 8 and 9. Make yourself a drawing. It's going to be very similar to the last one that I just did. You got two triangles that you know are congruent. It's telling you some side lengths in numbers and in expressions. So now you just got to figure out what the corresponding sides are that are congruent. And it works the same way as the angles. The ordering of the letters is everything. So for DE here in this number 8, DE is 18. Well, that's the first two letters in the first triangle. So that's congruent to the first two letters in the second triangle, JK. So you're just going to have to go through that process to match up corresponding parts of the congruency statement so you know what's equivalent to what. Questions on that, anybody? Now, the next page here is a bunch of maybe new acronyms, maybe not. But these 5 things you must know. These are the ways that triangles are proven. If we can't do it by corresponding parts, if we're not told what it is, then we're going to do it on the basis of these acronyms. SSS, SAS, ASA, AAS, and HL. HL is a special one. You don't see it very often because it only applies to right triangles. You can only use that proof with right triangles. No other type of triangle. No other. We don't have a hypotenuse leg situation in any other kind of triangle. So that's why we can only use it with right triangles. So when we start talking about proofs, this is where a lot of people historically really start to scratch their heads. So let me get to this next filled out screen. The thing about these proofs, and when we're proving that triangles are congruent, it's very specific. You can't assume anything. You can't guess. Well, I guess you can guess, but in order to prove the 2 triangles are congruent, we can only work with the information that we know we can verify that's actually there. You know, we can't go off of a visual. Well, that looks like a right triangle, so I'm going to use hypotenuse leg. And we can't do that. If we see this little box down here in the corner, then we know that it's a right triangle. Or if they tell us that this angle is 90 degrees, then we know. But beyond that, we have to work with what's given to us. So if you go through every one of these types of proofs and you start identifying what's congruent to what, you can see how each of these develop. Side, side, side. The only time that works is if you have all 3 dimensions of the sides of both triangles. Side, angle, side. You see from the tick marks what's congruent to what between the 2 triangles. That angle has to be in between the 2 sides that are congruent. It connects the 2 sides that are congruent. Not someplace else in the triangle. It might be a different proof if that's the case. Angle, side, angle is kind of the opposite of that. You got an angle on either end of a side. The congruent sides connect the 2 angles. Angle, angle, side is a little different. And it sort of works like if you start at one angle and you go up the triangle to the second angle, and then that side is connected to that angle that's congruent, there you have angle, angle, side. It's going to be on the opposite. One of the angles is going to be on the opposite side of your congruent angle. The other thing that you can see here with this hypotenuse leg drawing, the hypotenuse is identified again as congruent between the 2 right triangles. It is, remember, it's always opposite the right angle. So in this particular example, the leg that is showing as congruent is this short side. It could have been the long side here on the bottom. Doesn't matter which one of the legs is congruent. As long as one of them is, you can then use the hypotenuse leg proof. Questions on any of those acronyms? You're going to need to use these quite a bit. So make sure you get these written down someplace so that you can refer to them again. And you're going to see why here in just a minute as we actually try to write out a proof.
So is it only to like if the triangle is going to have those tick marks all the time?
You're going to have to put them there.
Oh, okay.
Most of the time, they're not going to be there. That's what you have to determine. And again, it can only be done from information that is verifiable. Because in your handout, those tick marks are not there.
Right.
And, you know, if we were all in class together, I would be encouraging everybody to put these marks on your copy. I don't know if anybody's doing that or not, but it would be a really good idea if you did. Because these visual representations of these 5 proofs should go a long way to helping you write out the steps involved in creating a proof, because that's what's coming here next. And right below that, you see it says reasons that sides are congruent. The first one says it's given, the first bullet point. And you see a little smiley face there. That's great. We love that. If they tell us the 2 sides are congruent, okay, now we got something. Look at all these different proofs. Every one of these has side in it somewhere. So if we're given that information that 2 sides are congruent, okay, then we're on our way. Definition of midpoint. Here again, those early definitions coming back to haunt you guys. What does a midpoint create for us if we have a line that's being cut at the midpoint? What is the result of that? It's written out right here, guys. Read the fine print. A midpoint will create 2 congruent sides. Great. So if this were to happen on on 2 triangles that we're looking at, now we've got 2 sides that we could say are congruent. So we either need an angle or we need another side to show for certain that 2 triangles are congruent. Now, the reflexive property is kind of a strange one. If you're not familiar with the reflexive property, let's see if I can draw it. It's a line that is congruent to itself. So I got 2 triangles here. This line right here that splits those 2 triangles, that splits that big triangle into 2 smaller ones. I don't know. I mean, I didn't measure this. It kind of looks like it might be congruent. But this shared line, this line here that runs left and right, that's shared by both of those triangles. That is a demonstration of the reflexive property. because it's congruent to itself. It's like think about a reflection in the mirror. So those words are similar because they kind of do the same thing. Reflexive property is something that will come in very handy in some of these proofs. So if this particular line also cuts this base over here at the midpoint, well, what else do we got? Now we got this side is congruent to this side. Reflexive property gives us this one. So we've got 2 out of the 3 things for side angle side, or maybe side side side. So anytime you're talking about these congruencies, there's no, you don't have to force a proof on any of these. The proof will kind of evolve as you identify the parts. So reasons that angles are congruent. Again, it starts off with a given. Angle A is congruent to angle E. Great, perfect, love that. Vertical angles. How many times have we seen vertical angles here in the last week and a half? And that was one of the first definitions that we looked at from the first day. You gotta be able to recognize a vertical angle by this point. And the simple part of it is just knowing that 1 and 2 there are congruent. Those are vertical angles. The other 2 are congruent also, 3 and 4. Anytime, that doesn't even look like a triangle. Who cares? It doesn't matter. We got lines that cross. We have vertical angles. Vertical angles are congruent. These 2 are congruent. And these 2 are congruent. Always, always, always. I know they tell you, your mom probably told you never say never, never say always, but in this case, you can say always because it's true. It's another reason why we like those definitions, because they actually work for us when we need them to. Now, the next 3, alternate interior, alternate exterior, and corresponding angles, only work for you if you have parallel lines. See, in the fine print here, it says must have parallel lines. You can still have these angle relationships if the lines are not parallel, but you no longer have the congruencies, because remember, those relationships with transversals and parallel lines create congruencies. So if you're struggling with the transversals stuff in Unit 2, maybe this will help make it more clear. The last bullet point there says definition of angle bisector. Hopefully you know what an angle bisector is. Another one of those early definitions. Anything that's called a bisector, it's the same as a midpoint, only now we're talking about an angle and not a line. A midpoint actually bisects a line. Every line going through another line at the midpoint will bisect that first line. Angle bisector works the same way. It creates 2 congruent angles. Here's another way that you can use, before I go on, does anybody have any questions about any of those reasons for sides or angles to be congruent? The bottom of the page here, it shows you how corresponding parts of congruent triangles are congruent can be used when you have a congruency statement. Perfect example. And if you analyze this, you'll see that the order tells you everything that you need. Again, for the angles, first position corresponds. A and D. B and E in the second position go together. C and F go together in the third position. They're all like that. And because it tells us that these triangles are congruent, we can absolutely rely on that. So there's no guessing about it. Congruence means we know the relationships between the triangles. So this next page, not going to do all of these. This next page gives you a chance to think about what some of these drawings actually represent. Can we prove by one of those 5 methods that the triangles are congruent or not? Do we have enough information to be able to prove that any of these in a particular way? So first thing here, problem number 1, cannot use side, side, side. I can rule that out right now. Why? Well, I don't have any information on any of the sides except for this one. It's just like the triangle I just drew. That's congruent to itself by the reflexive property, which is a good thing because now I can say this is angle, side, angle. I can prove that one by angle, side, angle. It shows me that this angle is congruent to that angle. This angle is congruent to that angle by the shapes there, the single half circle, the double half circle. So that one's angle, side, angle. What about number 2?
Side, angle, side.
What angle are you including? I don't see any information about angles on number 2. And I'm glad you said that though, Jonathan, because that's a perfect side, 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 right? Because this line here in the middle, reflexive property, it's congruent to itself. We know that the other sides are congruent because of those markings. And we know that this line, the diagonal, is congruent to itself because of the reflexive property. All right, number 3. We got a side and we got 2 angles, angle, angle, side, angle, angle, side. Looks like angle, angle, side to me. Number 4 ought to be an easy one.
It's the HL, isn't it?
Yep, that's the hypotenuse leg. And in this case, the hypotenuse is congruent to between the 2 triangles because of the reflexive property, right? Because it's shared between those 2 right triangles. What about number 5? Don't force it. It's got to fit one of those proofs. What do we have here? Where these lines cross?
Vertical angle.
Vertical angle. So we know that we got an angle here and an angle here that are congruent. The problem is that those angles are not between the two sides that are being shown as congruent. So we can't use side, angle, side. Remember, order is important here. The order of all these letters is important. There is no SSA, side, side, angle, or turn that around, you know what it says. There is no such proof for side, side, angle. So I don't think we can prove that number 5 is congruent at all. And it demonstrates what I mean about not forcing one of the proofs onto a drawing, because we can only use what is given to us. What about number 6? Doesn't look like we have very much information there, but we do have enough to prove those two triangles are congruent.
Is it side, angle, side?
Well, I don't think we can use that one because there's only one side in each triangle that we know for certain is congruent. Because of that.
Right?
What?
It's the one that's shared, right? The one side.
Yeah, but it's not in between. The bases are on the same line, but we don't have any dimensions. There's no tick mark there to tell us that it's actually congruent. Looks like they are, but we can't assume that. It's another reinforcement of what I'm trying to say here. We can only work with what we are given, despite how it might look, despite what you might think. There's no tick marks there. There's nothing to show us that this is the line you're talking about, right? The vertical line. Yeah, no, it's got to be in this kind of situation where you've sandwiched the two triangles together. These just are happen to be next to each other. What do these little arrows mean here? In fact, I was going to say it's very important, but it's really essential to solving this problem for number 6. What does it mean when we have those extra little arrowheads in the center or in the middle of our line somewhere? And we got one in each triangle. What does that tell you about those two sides?
That it extends indefinitely.
Well, these are closed shapes, so I think you're kind of on the right track, but that really doesn't fit in this situation. If the arrowheads were at the very end of those lines, then I would absolutely agree. But this is in the middle of somewhere. Has a special meaning. And if you guys have been making your drawings and taking notes about this stuff, I'm hoping that you remember that means that these lines are parallel. So if you don't have that written down in your notes, you need to make sure that it gets there, because that's the only way that you're going to know that this angle up here at the top of this first triangle and this angle down here in the second triangle are corresponding angles and therefore are congruent, because these two lines are parallel. Corresponding means same relative position. With parallel lines, corresponding angles are congruent. So we could say angle side angle. We could also, because of the same reason, say this angle down here is congruent to this angle down here. for the same reason. Those are corresponding. So make sure you remember what those little extra arrows in the center of your line mean. They're telling you that you've got a parallel line situation. And once you've got parallel lines, it sets up all of those congruencies between the angle relationships. Really, really important, especially on these proofs, as you'll see here in a minute. So here's the first proof. It says we will use definitions, postulates, and theorems from our toolbox from the handouts to write the proofs. Wow, got a drawing. Looks like a bow tie, angle or a triangle ABC, triangles CDE or DEC. Tells me what we have here is it tells me AE is bisecting BD, angle B is congruent to angle D. Now we got to prove that those two triangles are congruent. In this first column, the statements that you're going to put in here are the ones that you're given. So the first statement that I would write would be AC bisects BD. Well, and the reason for that is because it's given. It's given to us. The second statement might be something that's in relation to that. So if AE is bisecting BD, what does that tell us about any of the sides in that triangle, in those two triangles? Doesn't it tell us because it's bisecting that we end up with two congruent segments? That's what the bisect means. That's, remember, if we're bisecting something, we're cutting in half. Two halves are equal. So the next statement I would probably write would be BC is congruent to CD because of the definition of bisect. So now I got these two sides that are congruent, and it's going to tell me that angle B is congruent to angle D. So that would be the third statement I would write down. Well, here's B and here's D. So now I got angle and I got a side here on this triangle. I got an angle and a side on this triangle. The last thing I'm going to write is angle ACB is congruent to angle DCE. So these two angles right here in the middle, those are congruent. That's a statement I'm going to make. And the reason I know that they're congruent is because of the definition of vertical angles. So now what I've just done is I've got angle, side, angle, angle, side, angle. I've proven that those triangles are congruent by angle, side, angle. And all I did was just work with the information that was given to us. Okay. All right, here's a Jamboard with I'm going to go through 3 proofs here. I just shared it out to everybody. I got PQ is congruent, segment PQ or side PQ is congruent to segment RS. Okay, visually I see that here, PQ and RS. PQS is congruent to RSQ. Okay, so I'm going to start making some notations here. PQ is congruent to RS. So PQ is congruent to RS. And that's where I'm going to start my statements. I don't have a congruency symbol, so I'm just going to use the equal sign. And it's a given. Okay, now angle PQS. PQS is congruent to RSQ. RSQ. All right. There's an angle. Whoops, nope, that's the wrong spot. There we go. PQS and RSQ, there we go, RSQ, those are congruent, right? Single. So now I got a side, I got an angle, so I can put that next statement, angle PQS equal to angle RSQ. And that's also a given. So once you start looking at these things and you start identifying the parts that you've got that are congruent based on the information that you're given, you can probably visualize the proof that you're going to end up using. Because I've got a side and an angle, okay? If I have another side that's on the other side of that angle, then I can show side, angle, side. So can I show that this line here, QS, is congruent?
Yes.
Heck yeah. This is the reflexive property in action right here. This is how you can, it helps you to complete these proofs. QS is congruent to itself. And the reason for that is the reflexive property. So I'll go back in here and I'll mark that twice because that's the second side that's congruent to itself. If you pulled those two triangles apart, maybe that's a way to visualize it also and understand exactly why QS is in common to both of them. QS is going to be equal to itself even if you pulled them apart. So my congruency statement is then proven proven by side, angle, side. May not quite be the way that the wording goes in the teacher's handout, but that's really what we're given here. That's what we're talking about. And we could also say corresponding parts, congruent triangles are congruent. Because if you look back here at the congruency statement, PQ is congruent to RS. Well, that's what they tell us right at the beginning. Questions, anybody? Okay, and this one I had to really blow up because it's muddy already on the document. Hopefully you can read it. We don't even have a drawing. What is this all about? AE, we got a segment AE, bisects segment BD. Angle A is congruent to angle E. Now we got to prove these two triangles are congruent. And since I can't draw straight lines with this thing, AE, let's call that AE. Bisects BD. So there's B and D. So what do I know about this automatically? Okay. This, yeah, and that also, but because of the bisection, I also know that these two segments are congruent. So this must be point C here in the middle. So I got ABC triangle over here. I got EDC over here. you're absolutely right, Jonathan. Vertical angles here in the middle. It tells me that angle A is congruent to angle E. And so now, without even really doing the statements and the reasons, you can kind of see this is an angle side proof, because I've got an angle. If I just go around, follow the triangle around, angle side, angle side. Remember, the side's going to be opposite the other congruent angle. So your end proof is going to be angle side. And you go through the same process. We would write down the given AE bisects BD. Let me go ahead and do that. AE bisects BD. So that's a given. And before I even got to the vertical angles, I was able to say that BC congruent to CD, because definition of bisect. And then the angles, see ACB and ECD. There's where you throw in your vertical angle rationale. And then the last piece would be angle A. That's the last part of the givens. Angle A congruent to angle E. Reasoning's the same because it's given to us. It's what they tell us. So sometimes these proofs will unfold naturally. And if you remember these definitions, you'll be able to figure these out pretty straightforward like. So we're getting a little bit short on time here, so I don't want to go through this last one point by point, but it's very similar to the last one. And you can even see that the drawing is similar. It's got side MA is congruent to side TA. So even without writing any words down, I can put some marks on there to start seeing what's congruent to what. A is the midpoint of SR. So what is that? How does that help us? If A here is the midpoint of this line here, what does that tell us about these other parts of these triangles? It's the midpoint. It's bisecting, cuts it in half. Come on, guys. Give me something here. I presume you're still in the room watching, but I don't know. So I know that those two lines or sides are congruent to each other because of the definition of midpoint. Now, what do I need for a side angle side proof? It's easy. It's the angle in between. Has to be congruent. Well, it is. And how do I know that? Because of the definition of vertical angles. So hopefully running through those three examples gives you some reference for how people get tripped up on these proofs sometimes. It's not new information. Now, the parts that are in the handout that we just been talking about, side angle side, side side side, angle side angle, AAS, angle angle side, and hypotenuse leg, those are new. Maybe you've never seen them ever before, but you will be tested on them. So be sure that you know those. So I don't know if anybody's had a chance to get to this point yet in the packet with the Unit 3 study guide. Starts off with a section about mid segments. Do you know what formula to use for mid segments? Okay. If you don't, probably need to go look that up again. Mid segment connects the two midpoints of sides of a triangle. That connecting line is half of the line that is parallel to. So in this first example, this line MP here, that's a mid-segment line. It's parallel to JK, so it's half as long as JK. Or if you say it the opposite way, JK is twice as long as MP. So we worked with those definitions a little bit on Tuesday and did some calculations. Anybody have a question about the mid segment? There's only the one formula, and it's inverse. So that whole first page is about the mid segment. We did this next section here, topic 4 on Tuesday also. We tried to figure out through some simple calculations based on some side links whether or not something could actually close where all the sides could connect and create a triangle. Does anybody remember that rule? Inequalities in triangles. It starts off with the sum. The sum of what must be greater than what?
Must be greater than 10 and 22, right?
Yes, the sum of what though? What are you adding together that must be greater than 10?
Two sides.
Right. The two short sides must add together to be greater than the third side. So 22 is not a triangle, right? Because 5 and 2 is 7. That's not greater than 10. And then you got to be able to find the third side of a triangle too. And this could be bigger, could be shorter. Let's see if I can find that real quick. So here's the page that we went over on Tuesday about triangle inequality theorem. The sum of the two short sides must be greater than the third side. Otherwise, you do not have a triangle. And then to find the range, you're going to add them together or you're going to subtract. Because you could have one short side and or a longer side to create the triangle. What the heck does that mean? Okay, let's look at it here on the study guide. So if I've got this triangle, this in problem number 26, I have a triangle with two sides of 3 and 48. What must the third side be in order to actually close as a triangle? What number can I add to 3 that's going to give me more than 48? Can I use 45?
No.
Nope.
46.
Because that equals 48. Got to be greater than. So it could be 46. Right? So that's one possibility. So I could have a third side that's 46 kilometers long. On the short side, now I'm going to subtract 48 minus 3. I'm sorry. I'm going to add. What about 52? Make sure you go back through your notes and look at those. Section on ordering, least to greatest. There's relationships there between the side lengths and the angle measurements. Anybody remember what that was from Tuesday? Well, the angles are going to be the same order from smallest to largest as the sides are that they're opposite. So if you look at that example number 29, the shortest side is opposite angle B, so angle B is the smallest angle. Angle C is the second smallest angle because it's opposite the side that's second longest. Angle D is the largest angle because it's opposite the longest side. That's the way all these ordering questions will work. The order is going to be the same as whether you're talking about the angles and you know those, or whether you're talking about the sides and you have that information. Greatest to least. A lot of this stuff is marked as skip. You can see here, you're going to have to go back to the triangle angle sum theory. One of the first things that we did to figure out these angles. You've also got the little arrows here. What does that tell you again?
Parallel.
Parallel, right? So this line's parallel to this line. So that's going to set up some of those corresponding alternate interior, maybe alternate exterior, perhaps could be those relationships. Problem 6, though, is not the interior angle sum. It's the exterior angle sum theory. Remember, this angle here that's one on the outside of the triangle is equal to the total of the two that are opposite. So we could find x by adding 2x plus 20 and 5x minus 11, saying that's equal to 11x minus 63. So we're about out of time for today. So what I'm going to suggest, I'll probably post the this third unit test tomorrow. You'll have a week to do it like all these others. So if you're working on, if you're comfortable with all this, you want to just dive in and take the test, go for it. If you need some help on something though, use that test study guide, work on some of that. You know, send me pieces of it, take a picture of it, send it to me, or I can give you feedback. I only have I have 2 appointments tomorrow, so I might not be able to get back to you right away, but I will get back to you because tomorrow's office hours day. Questions, anybody? All right, we are out of here for today.
Is that the study packet that we were just in? The
Yeah, that's the end of,
study packet.
yeah, student virtual study guide. Yep. Okay, Audrey. See everybody on Tuesday. Some of you I'll see in a minute.